According to Einstein, space isn't simply a void. It's more like a four-dimensional fabric woven from both space and time. The mass of planets can warp and distort the fabric, gathering other celestial objects like moons around them. And it's this bending of space-time that creates the effect we experience as gravity.
The problem that Einstein had is when he solved his equations of general relativity, what he found was that he predicted that the universe should actually be expanding. And that was radically different from the perceived wisdom at the time, which is that we lived in a static universe, both static in time and in space.
So he put in an extra term into the equation. He called it the cosmological constant. He used the Greek variable lambda, but effectively it was really just what a physics undergraduate would call a fudge factor that was just designed to make the equations come out right, and it would just make the universe sort of stand still.
In the US, an astronomer, Edwin Hubble, was about to get a reputation for scientific cleverness himself. He'd been using the world's largest telescope at Mount Wilson in California to peer deeper into space than anyone had ever looked before. What he discovered completely changed the meaning of the word universe. Until Hubble, it had been thought that the universe was our galaxy. What Hubble saw was that, in fact, our galaxy is just one of countless millions, but more importantly, that all these galaxies were moving apart from each other. The universe wasn't static after all. This had huge implications. It introduced the notion of a beginning and an age for the universe. But more importantly for Einstein, it meant that he could ditch his fudge factor, the cosmological constant, and return general relativity to its former glory. Einstein was over the moon. In 1931, he went to Mount Wilson to shake Hubble's hand and thank him for putting beauty back into his equation. Lambda, he later confessed, was the biggest blunder in his career.